Okay, our next discussion is about the biological treatment. So we have choices here: MLE, SBR, two types of MBBR, MBR, and IFAS. So for this discussion, we'll be focusing on the MLE. So an MLE is just really a conventional activated sludge with a pre-anoxic tank. So it looks like this. So there's an anoxic tank here, an aeration tank, and a clarifier, and then you have a internal recycle. Okay, so our goal is to size all these three tanks here, mainly the aeration tank. Okay, let's start. Let's click example here. So this is the total flow rate. We will be inputting here the flow per tank. So we'll just click it that 10,000. And then we'll do 4 duty and then no standby. Typically, there's 3 duty and 1 standby, or there's a standby tank. But for now, let's assume that space is very limited, so we don't have enough space. And then we'll just get the BOD after the primary clarifier, which is 124. And this is around 40. Okay. Temperature, let's increase it to 25. Okay, this is too high. You just increase it to 50, the effluent. Okay. Okay, we'll just maintain this as 80. Okay. All right. So let's focus on the aeration tank first. The factors that affect the aeration tank are the flow rate, the BOD, temperature, and all these parameters here. So they affect it. So the increase your flow rate, if you increase these influent parameters here, except the temperature, you will increase the aeration tank. But if you increase the temperature, your aeration tank will decrease because there's more bacteria tends to thrive at slightly warm temperature, so there's more activity and then they can degrade more bacteria, so you don't need as much volume. But if it's colder, then this bacteria activity is slow, so you need a bigger volume. Okay, and then let's just check the MLSS here. So I want to reach 1,000. Okay, so maybe we could increase it to make it more concentrated. Okay, 40. Let's see here. Maybe this is 10. Let's try 10 here. Okay. All right. So, but this really depends on the influent parameters. So right now I'm working in reverse. I'm targeting a certain volume, but usually the case, it's actually whatever you input here and whatever results here, that's the volume. And then if you want to change it, then you have to find a way that your influent parameters are low. These values here are low except for the temperature. So we have our aeration tank volume. Okay, now this is the internal recycle. So let's see if there's removal. Okay, removal. Let's see. So unless you really like wanna delve into the details, so since all these are output, you don't really need to like check that, but you have to check this ammonia here. So if you're satisfied with that, then there's enough denitrification that would happen, and that's okay. So this 20%. So if you want to lower this one, you can. Let's say if you want to decrease this. Okay, fine. So if you decrease this one, let's say 10. See, the more you increase the volume, the greater the removal. Okay, so for now, let's say it's actually usually 20%. So let's say just 20%, just to be safe. So this is your anoxic tank volume, and then this is your ammonia here, which is fine. Okay, All right, and then this is your aeration here. So okay, let's check first the dimensions. We have a volume of around 1000, so we'll just do what, 10 by 10. All right, and then we'll just, okay, we have all right, again, I emphasize that you have to have background on how to design this, and this will make it things easier. So if you're not confident, it's better to like understand the concepts first, right? So okay, so let's draw a tank here. Okay, our tank could look like that. So this is only for the aeration tank. Okay, we don't have sizing for the anoxic here. We can't see the anoxic here. It's gonna be in a different topic. So lastly, we just want to look at the clarifier. So we applied a hydraulic application rate of 24. For now, let's just maintain that. All right, and then we go to generate report. All right, so this is our report. So it's a total flow rate. We have tank duty 4, average flow rate, and blah blah blah. And these are dimensions, and we can print this, and that's it. Okay, we're done with the sizing for the aeration tank.